All right, one more talk to wrap up our morning session here. Thinking more about data access and where we can find some of these data resources that we might not know about. We have Doug Schuster from NCAR Sizzle Research Data and Archive at the RDA. Welcome, Doug.
All right, well, thanks for the opportunity to join today's Unidata Users Workshop. I'm going to be going a little bit higher level than some of the more recent talks, and I appreciate those as well. We have a lot of users that work with our resource called the Research Data Archive at NCAR, and we're really pushing them to go to some of these X-ray tools, and modernize their workflows. As you can see, you can do a lot more with some of the tools that are available now than have been in the past. So, once again, I'm Doug Schuster. I'm from NCAR. I manage the group that maintains the Research Data Archive at NCAR, and I'm also the acting director of the Information Systems Division at this point in time. So, my talk's going to look at how do I find a data set of interest and access it, and I'm going to be going in a little bit of, what was my background actually in getting into data. So I'm going to be telling my story about how I got into data, and sort of relates to these stories about how do I tell a story with data, hopefully. So a little bit about my background. In undergraduate, I actually went to the University of Minnesota and studied civil engineering. I had some internships in civil engineering. I was actually initially interested in atmospheric sciences, and growing up in Minnesota, why are snowstorms forecast? Why do we get a winter storm warning and it doesn't happen? So I get frustrated with that one. Then I was also interested in nocturnal thunderstorms. Like, why do we get thunderstorms at night? That doesn't make any sense because it's cold out at night. But I initially was nudged out of atmospheric sciences, when I went to a few different schools. They're like, the job market's not that great. And this was in the mid-90s or so. So I went back and did civil engineering. But then I did some internships, and I'm like, really don't want to do that. So that's how I ended up at grad school at Colorado State University in atmospheric sciences. And then this was back in the late 1990s. So when I went out to CSU, I'm like, okay, yeah, I'll pretty much be out there and do a lot of hikes and things, and you learn some, learn a little bit about the atmosphere, but I was really excited about hiking. But that wasn't exactly how it worked out, so I was sponsored by Dr. Bill Cotton, who was my advisor at that time. I was basically given an office space in front of a Dunn terminal, and there was a ./ on there. Well, how do you do this? Because I went to undergraduate for civil engineering, and everything was Windows-based applications. So it was a bit of a shock. And then the other aspect of this was, okay, now you need to run the regional atmospheric modeling system from this ./ So, okay, how do I go about doing that? Yeah, okay, well, I was really set up to actually run a project where I was supporting a field project for the Earth Observing Laboratory, or that's what it's called now, and running real-time forecasts over Kansas to support what's called the Cases 99 study. And then you'd get sidetracked every now and then. The advisor would ask me, I'd like you to run in simulation of this atmospheric bore event that occurred over South Africa in 1997. But this is kind of what brought me into how did I get involved with data. Okay, well, that's interesting. How do I do that? Get reanalysis data, initialize, and nudge the model. And I was a graduate student. I didn't really know too much at that point in time. I was getting my feet wet. How do I get reanalysis data? And this is a different day and age. So, talk to the research associate who, really develops the model. He'll get you the data. Okay. So he got it. I'll get it, and I'll put it in your home directory for your cluster that you're running from. It was actually a Linux cluster. They migrated from AIX to a Linux cluster at that point. All right, thank you. I see a bunch of files named Y, something, something, something. Now what? Figure it out. So that's what you did. Figure it out. And, I think actually going through this talk, a lot of this honestly applies to this day and age with what we do. But, if it was this day and age and I didn't, how do I go about finding a data set of interest for my project? So what's you have a research question of some kind. Most of the time we're not like, I'm just gonna go look at GFS forecast data for fun. Maybe we do, in some cases if it's real time and I'm looking at a specific event, but what caused a bore event in Arizona during the afternoon of a specific date, something like that. And then what tools and data do I need to answer my research question? In this case, maybe it's the WRF model this day and age. I need input data to initialize and nudge my simulation. And then probably truth data to validate my model results. Okay, that's pretty general still. So what are we looking for a little bit more specifically? Probably some kind of gridded analysis or reanalysis product, in situ observations of some kind, and then possibly other platforms such as radar data. Are there field projects that have been run in that area? There are a lot of questions out there. Then what are the specific data sets that I need? Where do I get them? Ask your advisor. That's still actually a very good resource to go. That's probably your first step. Or your colleagues. I think a lot of people end up getting the data they need going through that process, honestly. But then, typically people go to the search engines they're familiar with, such as Google. And I tested that out, so we asked Google. Reanalysis data. What is reanalysis? Reanalysis data provide the most complete picture currently possible of the past weather and climate. So that's a good answer. But if you look up here, actually, if you click on these links, it actually has some relatively good information here for various reanalysis products that are out there, including the ECMWF ERA5 reanalysis. But there's been a lot of work. So those of us that are in cyber infrastructure, a big area of research is improving search capabilities for data sets. There's all kinds of efforts that are out there to really support that. And the commercial search engines have really built upon this. So if you pull up the slide deck that's in the folder for this talk, you can click on some of these links. So Google has a data set search platform they've developed. So it's specific to searching various data sets. And the way this works is repositories and data providers basically provide a subset of metadata that these commercial search engines can go out and scrape. And then this search tool, keys on that information. So you get specific data sets in the results versus things like you saw in the wiki result from the prior slide. But the top result, once again, is ERA5 reanalysis, which I think is a pretty good job. There's a lot of other options out there in terms of federated data search services. The European Space Administration has developed a tool called the GEOS Portal. So that's basically an aggregation of metadata that's contributed by a variety of data repositories and information websites. Once again, though, you go through a search of that and you can come up with tens of thousands of results. It's challenging to find what you want. And then you have data.gov, which covers all of the NOAA resources, amongst other things, EPA, other labs. So that's another place to go if you're looking for data sets of interest. But you come up with thousands of results once again. As you can see, there's 251,007 data sets available, or 253,000. So there's a lot of resources on there. And then we have the organizational search alternatives. So NOAA has a search tool they've developed if you're interested in, perusing the various NOAA resources. There's actually two options on there, but that's one place to go to look across everything that's at NOAA. And then NASA has an Earth data search tool if you're interested in NASA platforms or data sets as well. But once again, these can be kind of challenging to use. Another one that I have on here is the Copernicus Climate Data Store. That's a popular data set or popular resource for many of the users of the RDA. It hosts ECMWF reanalysis, and I'll get into some of the capabilities to access that later through the CDS. And then it hosts a number of other climate-related data sets and resources, but they have their own catalog. And then NCAR and UCAR get under the act as well. So historically at NCAR and UCAR, there's a number of different services that support data repository and data access, such as those at EOL and CISL and RDA, amongst others. And there's a tool that was developed called data.ucar.edu, where you can search across all the resources that are housed at NCAR and UCAR, and it includes access to different Unidata tools as well that are registered in that service. And then if you weren't aware, the commercial cloud providers have gotten into this act as well now. So there's open data programs, or what they're called, and Amazon, Google, and Microsoft. And a lot of the data sets that, the high priority data sets that NOAA provides are now available through these resource providers. So a lot of times users will come to the RDA and they want GFS data for historical purposes. So we have the GFS deterministic data sets in the RDA going back to maybe 2017 or something like that. But a new resource is to go look at some of these cloud providers to actually access those data sets if you want to download them or actually analyze them using data proximate compute on the cloud resources. So that's an evolving space, and I think these resources are going to become more important over time, and they already are very important. And then we have the near real-time options. So some of the data sets I mentioned from NOAA are actually available on those cloud resources in near real-time. You have the popular Nomad server. I'm sure many have used that. If you hit it too much, you get throttled and hit. And then you have the threads catalog that Unidata supports. They have the threads.ucard.edu. And then there's also the one on the Science Gateway that you've probably been able to access through this workshop. And then finally, what I have on here are the ECMWF weather forecasts. So ECMWF has recently moved to open up much of their data actually for near real-time access. So they have capabilities on their own infrastructure to access their data sets. And then they also are copying their data to Azure and AWS, and these are in European regions, but that's kind of how they're moving. They're starting to move to the model of pushing data out to the cloud for use because their data is becoming so big and challenging to access. And the UK Met Office is doing something similar. They have data that's stored on Azure as well. Once again, those are a lot of resources and tools out there to find data sets, but really what's fit for purpose for your research use case. There are a few tools out there that have that type of information, but one that I want to point out is the Climate Data Guide at UCAR, so that's the links on this slide. But the whole purpose of this resource is to provide expert guidance on data set characteristics. So if you're looking at a reanalysis product or a rainfall product, what are some of the pros and cons, strengths and weaknesses of those data sets? And what research have they been used to support in the past? So that's what this tool provides. So it's really I want to know what's the suitability of a data set for my research question. That's the point of this climate data guide. So hopefully that will help you narrow down, what you need out of a data set. But it's challenging. What data sets do I need? Where can I find them? As we just went through, I'll reinforce this. Ask an advisor, ask colleagues. What are they using? What's popular? What's easy to access? And then another, area that I recommend is reviewing an evolving area, which is data citations and journal articles. So now a lot of journals are asking authors to formally cite their data sets in journal articles. That's a great resource to look at if you're, doing a literature review of articles of interest for whatever your research is. Look at the data that's cited in those articles. And on the flip side, if you're looking at a data set of interest, a lot of those landing pages now have links to all of the articles that have cited those data sets. So that's also another area that you can look at, is this data set fit for purpose for my research question? And then, if that fails, go to Google Dataset Search. I'd recommend that over strictly Google as a starting point, and over all these other resources that I described. I think that's a great starting point to go to. Now, how do I access a data set of interest? I'm going to go pretty high level with this one because the experts are here that are discussing this, using the various Python tools and capabilities that are out there. But we have kind of the legacy model that as a repository that RDA has supported historically and other places such as Nomads have supported. So this is where you point and click or download files via script. If you are going to do that, I recommend a service called Globus if possible. That is a fire and forget tool where you can basically pick a big bulk set of data or folders of things and point it to your endpoint or your local system and hit go, and you don't have to monitor it at all. It takes care of all that in the background for you to move something to your local system. This method typically requires lots of data volume to be transferred, and then once it's on your local system, you really have to clean and organize that data to get it ready for use, for however you're going to use it, whether you're putting it into a model or whether you're analyzing it. So this can be pretty time consuming. This this image comes from Ryan Abernathy in one of his Pangea talks, but that's the 80% of organizing, cleaning, doing all this stuff to get data ready for use, 20% actually looking at the data. A lot of what we've been talking about so far, what I've seen today, are web service models, and many are offered by the Unidata Threads data server. So this is the OpenDAP model where you point to a web link, or OGC if you have web map services, those types of things. And then you can use something like a Jupyter Notebook or Unidata's IDV tool. And then you can do some data exploration, without having to move full data sets to your local system. This can be dependent on the server that's serving the data and the network performance that's sitting on that server between your system and that server. But this is a great way to explore data without having to move lots of data. And then there are tools out there that allow you to submit batch data requests for subsets if you want to move subsets over to your system. The RDA supports this, and the Copernicus Climate Data Store, that's another resource that supports subsets. And in general, this reduces data volume. You get subsets transferred or streamed to your system. So this is a good way to do things. And then data proximate analysis. That's where things are moving in general, and the area that's being promoted to look at data. And we've done a bit of that today using the gateway that's running on Jetstream and some of the data sets that are located on Jetstream. In this case, we are using some APIs and things to read data from other resources running on Jetstream. But it also, for data proximate analysis, the big point of doing this is you get direct read access from compute resources co-located with data. So you don't have that whole cleaning step and moving things around. And in the end, the hope is that only the results are transferred, plots, figures, those types of things. And you're able to leverage an ecosystem with some of the tools and libraries that have been described in the talks today on a common platform. You log into that and have something like a web browser that can access that, and you don't have to move lots of data around. And then the other hope is that the data sets are in what are called data or analysis ready data formats and structures. So you can just use one line of code to access a data set and visualize and view the metadata that we've just looked at in some of the prior talks. So I'm just going to go through a few examples of what data analytics platforms are out there. So another one I'm going to highlight and shout out is the Copernicus Climate Data Store Toolbox. This is one that's supported by ECMWF, and it's open to anybody for use. And basically through that, you have a toolbox editor, as you can see down here, and they have libraries of different capabilities where you can access data directly from ECMWF or providers that will stream data in that are European partners typically. And then over here, another nice resource is actually a catalog of applications that have been developed on the Copernicus Climate Data Store Toolbox. So let's say I'm charged with developing a specific application to look at temperature, over a certain region or state and compare it to health data. That's typically what these are. So you can search through all these different applications. If you click on one, it has different widgets. It's like a dashboard, so you can view characteristics of a data set. Then you can actually view the underlying code that was used to drive that dashboard, and typically those are Python-like. And moving forward, in the next iteration of the Climate Data Store, they're going to move to more open source capabilities. So right now they have a custom toolbox editor, but they want to go to more of a Jupyter Hub model, and making everything a little bit more transparent. So that's where they're moving. But this is a good resource if you don't want to move lots of ECMWF or other large data sets around and go do some exploration. NASA's recently, started to move all of their data onto Amazon Web Services. So all their data is now stored on AWS, or moving that direction. And the reason they're doing that is because their data sets are becoming unbearably large to move around and deal with. But the way they're going at it is they have a set of tutorials and webinars out there on really how to enter the cloud and start using the cloud without platforms necessarily. But how do I lift my workflow that I might have on my laptop and put that on a cloud resource and enter that arena? So that's kind of how they're going. That's available, open to anyone, but you still have to have money to pay for the cloud resources. And then we have these commercial cloud provider analytics platforms. You might be familiar with those, Google Earth Engine, and then the Planetary Computer for Microsoft. And you have access to a lot of these NOAA data sets that we've been describing and capabilities. And those are typically free for non-commercial use. and for research purposes. So I'd encourage users to go out and explore some of those capabilities. And then we have other platforms, and I think we've gone through some of this today, but Pangea, they have a pilot Jupyter Hub that's running, I think, on Google Cloud, but you need authorization. It's kind of limited in what it can do, but it's good for initial exploration if you want to get familiar with how some of these capabilities run and work. And that community is great if you have questions as well, the Pangea community of practice. The Unidata Science Gateway Jupyter Hub, we've been using that today, and you can see how nice that is when you spin up your instance and you actually can, run operations and visualize data sets and do explorations on that resource without having to configure all that stuff on your own laptop. Then NCAR is in the act as well. I didn't update the link there, so you see the Science Gateway at Unidata once again, but the NCAR Jupyter Hub, if you look it up with CISL HPC computing accounts, there's a Jupyter Hub at NCAR. And basically, what you need for that is if you're running on the CISL HPC systems already or have an account on that, you can spin up a Jupyter Hub instance, but it's kind of complicated to get going. You need to know basically a PBS batch script to enter that at the beginning to configure that so it gives you the right amount of resources to do whatever your job is. So it's got a little bit higher of a user entry requirement, I would say, but we have one going. And then we also have data analysis allocations, and I recommend this for users of the Research Data Archive. So this allows users to either access, the Jupyter Hub environment that I just described, or get logins on the Casper data analysis cluster and run more traditional batch-based command line workflows. And these allocations are available to researchers from any institution, university, for instance, regardless of the source of funding, as long as you identify the specific NCAR hosted data sets that are essential to completing your science objectives. So anyway, I really would suggest users, if you're familiar with the NCAR systems, to get on there and do that instead of trying to download data. So just to summarize this talk, it is challenging to find the right data to answer your research question. At least that's my experience. So I think asking a colleague, advisor, those are really the first places I would go. And then, use a familiar search tool, or if you're familiar with a certain website or resource, go there. If they don't have it, ask a question to the consulting groups that support those resources. And then there's all kinds of ways to access data sets of interest. Moving forward, I think we're going towards data proximate compute and data analytics platforms really to analyze large data sets. So that's all I had today. Thanks for the opportunity to talk.
Questions for Doug? Talk about a wealth of great resources there. I was constantly typing in bookmark. They are also available. Somebody put in the chat a link to the slides, so you can always have access to those. But we'll take questions right now. Russ?
Thanks, Doug. Great stuff. If you're thinking sort of the RDA in 5 years, your data sets are only going to explode just like all these other ones. Like, kind of what are you doing? What are you thinking about in terms of how to manage the the huge volumes that you'll be dealing with, and to encourage people to work with it in efficient ways?
Yeah, so the RDA and then also all the climate data sets that come out of NCAR, that's where this data proximate compute, emphasis goes. But we're starting to explore, what a data commons would look like at NCAR with the data analytics platform on top of it, kind of to reduce the barrier of entry so one doesn't have to necessarily get a Casper account or something like that, but make it a bit more open and available. And then, we want to pursue these strategies of making the data sets, structured in more of these analysis-ready formats so you can enter one line of code to access that data, and get rid of, like right now there's a lot of subsetting, legacy, batch, subset, download, and then, we complement things with threads. But I think we want to get more to, what's going on in this community and get the data sets such as ERA5 and such as the climate model outputs and other things like that into more of an analysis-ready structure so that if we continue to support subsetting services behind the scenes, those workflows, let's say I go through a UI and I click and say I want temperature or something, what runs behind the scenes will be the same workflow that I would run if I was running my own Jupyter notebook, basically. So that's where we're trying to head. And then getting the observational data sets that are supported by EOL structured for easier reuse by other communities outside of observationalists. That's another area of focus.
I know a lot of these tools require sort of asking colleagues or trying to find resources and stuff like that. What sort of strategy is like RDA or your group and stuff like that taking to sort of educate people on how to use like these new platforms and how to sort of scale it up where it's not, because sometimes that can be like exclusive if you have to like ask like a certain person, kind of like you were saying at the beginning, like if you have to know a person, not everyone might know that same person. But yeah, like how important do you think like education, outreach, like putting time into like some of these different educational materials as well?
Yeah, so as part of this data commons development plan, we'll see where that goes, but there's a big component on consulting on education, and we'd like to work with Unidata in that component as well, because this is a great venue for doing so. But I think efforts like Project Pythia, those are the types of efforts we'd like to leverage, as well as working with communities of practice such as Pangea. So that's where we'd like to push that information out over time, and then hopefully there are champions within those groups that other researchers can look to that are using these tools and will assist in answering questions and propagating some of that information.
Any final question? Anything online?
I don't see anything online.
Okay. Good.
I just want to say, as a long time user since graduate school of the RDA, thank you for you and everyone there for all of that effort, especially accessibility via threads. It's honestly been game-changing for me and my students, both for research and for teaching.
Thanks. And I'll just mention the RDA recently removed its authentication requirement for file download. So file download and threads. So we're getting there, and then there's actually a standalone threads server now called threads.rda.ucar.edu. So point your legacy scripts to use that, because the current one's going to go away at some point. So we're just trying to break up our services into different resources. So they're not all working on one thing. Yep, but please let me know if you have questions with any of that.
All right, let's thank Doug one more time.
Thanks.